Hello everyone. How's your week so far? I hope all your online classes are doing great. Okay. Now before we're going to start, let me remind you again, make sure you have your pen and your notebook with you. Take down notes of all the important details and all the things that we're going to discuss in this topic. Alright, make sure you understand all of it, and if you have questions, feel free to send me a message and I will be very glad to answer you right away. Alright, now once you open this, also by the way, make sure you comment the word present so that I will know that you are already online. Okay, thank you for that, and I'm expecting everybody to be there and be present. Alright, now today we will be discussing two topics. First is HCF or GCF and LCM. Second, we will have laws of exponents. Now, what is HCF? HCF is the highest, or we call it commonly, it is known as the greatest common factor, or the GCF. Now, GCF or HCF is a set of numbers in a largest number that is a factor of all those numbers. Means to say you have all those kind of different numbers, you factor out and you find the number, the highest possible number that is common between those numbers, and you call it greatest common factor. All right, or the largest multiple of that number that is common to everybody, no, to every number out there. Okay, that is what we call GCF and HCF. All right, the highest or the largest number that's a factor to those all of the numbers. Now, here are steps on how to determine a GCF or a HCF. First is list the prime factors of each number. Take note of the word prime factors. Prime, these are numbers with a multiple of 1 and itself, right? So multiple of 1 and itself. All right, prime numbers, these are numbers that has a factor of 1 and itself. Okay, next is circle every common prime factor. So means to say, after you list down all the numbers, all the prime factors of a corresponding number, encircle the number that is common between those numbers. All right, so that you will identify which of those factors are common between those numbers given. Third, multiply all the circled numbers. So means to say all the common numbers, it could be 1 or 2 or more, multiply, only common, right? Even if it's repeated, you only take 1. You multiply the 2, and the result will be your GCF or your HCF. That is how we determine the highest common or the greatest common factor. All right, first, list all the prime factors of a corresponding number. Second, all right, encircle the common numbers between those two given numbers and multiply the common number, and the result will be your GCF. All right, let's have an example here. Suppose you want to find a GCF of 28, 42, and 70. Step 1 says list all the factors, prime factors, right? List all the prime factors of 28. Now 28, you have 2, 2, 7. So means to say you have 28 here. Yes, you have 4 times 7 and 2 times 2. You have 42. All right, you have 6 times 7, and then this one is 3 times 2. You have 70. You have 10 times 7, and you have 2 times 5. Notice all the numbers here, all right, all the numbers here, they are all prime numbers. 2, 3, 5, those are all prime numbers. That when you find a factor, you only multiply that number and 1. All right, so when you list all the prime factors here, you have now 2, all right, you have now 227 for 28. You have here 227 for 28. Next you have 237 for 42, and then 257 for 70. And then we encircle the common number. You have here 2, you have 2 here, 2 and 2, you have 7, 7 and 7. So each of these have 2 and 7, right? So we take the pair, all right? We take a pair of number, let's see this, so that would be 2 times 7, all right? 2 times 7, the result is 14. So therefore, the GCF of 28, 42, and 70 is equals to 14. So this is now your GCF or your HCF. All right, I hope it's clear. Take all the steps. First, find all the prime factors. Second, encircle the common number. And within those common number, choose a pair and then multiply them. The result will be your GCF. I hope it's clear. Next, what is a least common multiple, or we call it LCM? The least common multiple, or LCM, of a set of numbers is the smallest number that is multiple to every set. If GCF and HCF is the largest number, LCM is the smallest number, all right? Smallest. It's the other way around, okay? It's the other way around, all right? It's the opposite of HCF and GCF. Now this is not a GCF, we'll use that for LCM. All right, that's not a GCF, that's an LCM. Steps on how to determine an LCM. First, write down the prime decompositions of all numbers. Second, for each prime number you find, underline the most repeated occurrences of each. Third, multiply the underlying numbers to get the LCM. Let's have an example. Find the LCM of 6 and 8. 6 and 8. So you have to find 6, the multiples of 6. Yeah? For example, you have 6, you have 12, you have 18, you have 24. Yes, this is for 6. Next is for 8. Now for 8, we have 8, 16, 24, all right, what else, 32, and then we stop from there. Now if you're going to look at the given between 6 and if you start from the very beginning here, you have to choose the number that is from the very start that is common between these two numbers. We can find 24 here. So 24 and 24 is common between 8 and 16, but it's the least common number that we have. So therefore, the LCM, okay, of 6 and 8 is equals to 24. Yeah? Next. Right, next guys, we will discuss about exponents, power, and indices. Now, what are exponents, power, and indices? Exponents, all right, exponents are the shorthand of repeated multiplication. Repeated because you're going to multiply, for example, 2 to the power of 2. You multiply 2 by itself twice because of this. So it becomes 2 times 2. If you have 4 to the power of 3, so means to say 4, you are going to multiply it 3 times because of 3. So 4 times 4. It is repeated because the number is being repeated based on its exponent. That is what we call exponents. That's a function of exponent. Now, we have certain rules when we try to solve using rules of exponents. Okay? The first one is rule of 1. So it means to say any number that you multiply to 1 gives you the same number. It's a mirror. Right? When you consider 1 as a mirror, when you look at it, all you can see is yourself. So therefore, any number that you multiply to, any number that is raised to the power of 1 gives you the same number. Yes? Okay. So therefore, there are rules of 1. First, you have to remember two things. Any number raised to the power of 1 equals itself. It makes sense because the power shows how many times the base is multiplied by itself. Second, 1 raised to another power is logical because 1 times 1 times 1 is equals to 1. So therefore, for example, you have here the pattern x to the power of 1, of which x could be any number. Alright, x could be any number. So if you raise, for example, 3 to the power of 1, that gives you 3. Alright, that gives you 3. And you have to remember, guys, secondly here, and a 1 raised to the certain power, it gives you the answer is always 1. So that's the first rule of exponent, rule of 1. Second rule, product rule. From the word itself, product means to say you are multiplying. Alright, product rule. Exponent product rule tells us that when you're multiplying two powers that have the same base, alright, mark the word, same base, you can add the exponent in this example. For example, the pattern is this. Look at the pattern. X to the power of m times x to the power of n. Notice the base are the same. They are both x. And the exponents is different, m and n. And the result will be copy the base. Alright? The result will be copy the base, add exponents. So therefore, 4 to the power of 2 times 4 to the power of 3. Copy 4, add exponents. So 2 plus 3 is 5. So that's why you multiply 4 5 times. 1, 2, 3, 1, 2, 3, 4, and 5. Okay, so the answer is 4 to the power of 5. That is a product rule. Third, we have the power rule. Alright? And power raised to a power. A power raised to a power. For example, this is the pattern. Alright? xm multiplied to n, it gives you xmn. Alright? A power raised to another power, you multiply the powers. So 5 raised to the power of 2 raised to the power of 3 becomes 5. 2 times 3 is equals to 5 or 6. So you multiply this 1, 2, 3, 4, 5, 6. Alright, this is what we call power rule. Next, quotient rule. Quotient means from the word division. You divide. Alright, you divide. So therefore, if you have x, look at this, x to the power of n divided by x to the power of n, it is xm divided by xn is equals to xm minus n. As long as this one is not equal to 0. Alright? As long as that one is not equal to 0. So when you have a division and you have the same base, you have to subtract exponents. So if you have 4 to the power of 5 divided by 4 to the power of 2, you just cancel common terms because it is minus. So that's why you have now 4 to the power of 3, or 4 times 4 times 4. This is what we call quotient rule. Next rule, zero rule. Zero from the word zero. So it means to say an exponent of 0. Any number raised to a power of 0, the answer is 1. So therefore, look at the pattern. As long as this one is not equal to 0. So if you have 2 to the power of 0, the answer is 1. 300 to the power of 0, the answer is 1. So no matter how big the number is, but when the exponent is 0, the answer is automatic 1. Next, last one, negative exponent. What is negative exponent? From the word, alright, from the word negative. So negative exponent is that you have an exponent that is negative. So if you have x to the power of negative n, yes, You have to make this one into positive. How? You have to put it on the denominator. So therefore this one becomes 1x to the power of n. What if it is 1 to the power of x negative n? So therefore you're going to change this to x over n. Alright? That's how this negative exponent is being done. Alright? So that's the last exponential rule that you have to remember. Alright? First is the rule of 1. Second is the product rule. Yeah. Second is the product rule. Next is power rule. Next is quotient rule. That's the fourth one. The fifth one is zero rule. And the sixth one is a negative exponent. So remember all those 6 rules of exponent so that you will be able to simplify any equations or any expressions that is raised to a certain power or index. Alright, so you have to remember, exponent is also called power, exponent is also called indices or index, exponent is also called roots. There's a lot of names, there are 3 other names, but the rule that you're going to follow are the same. First, rule of 1. Second, product rule. Third, power rule. Quotient rule. Zero rule. And negative exponent. I mean, there are 7 rules that you have to remember. Okay? There are 7 rules that you have to remember. Next, guys, I hope you're taking down notes and you listen very carefully on the things that we have discussed today. Now I'm going to review it to you so that you will have the idea what are we talking about today. First, what is HCF, GCF, and LCM? GCF and HCF is the same. They're looking for the largest common factor, common between any given numbers. LCM is the least common multiple. Multiple means numbers that you use those numbers to multiply. The least, that is the same. Next is the law of exponents. What is the law of exponent? It is a shorthand of our repeated multiplications. When you do shorthand repeated, means to say you multiply the number or any expression by itself. Right, by itself. Now there are 7 rules, basic 7 rules that you have to follow. First, first is the rules of 1. Any number raised to the power of 1 gives you the same number. Second, the product rule. If you have common base, the base are the same, alright, and you multiply to another base which is the same, you add exponent. Copy the base, add exponent. Third, alright, the power rule. An exponent raised to another exponent, you multiply the exponents. Fourth, the quotient rule. Alright, when you multiply, alright, when you divide a certain exponents, you subtract exponent. Alright, subtract exponents. So it means to say you have to cancel common terms to that. Fifth is the zero rule. Alright, the zero exponent rule, that any number raised to a power of 0 is equals to 1. No matter how big it is, once the exponent is 0, it is equals to 1. Sixth is the negative exponents. Any negative has to be made positive. So you have to move it down to the denominator or move it back to the numerator as long as this exponent will become positive. How are you going to do that? Move it. Move it to the numerator or the denominator. These are basic exponential rules of which if you're going to memorize it, you become familiar with it and then it will become easy to simplify expressions because exponents is always a part of any algebraic equations. Alright, so I hope the discussion today is clear. If you have any questions, feel free to write a comment in the discussion box and I'll be very glad to answer your questions. And once again, after you watch this one, I have attached a practice worksheet. Make sure you answer that, submit it on time, and I need you to take photo of your notes, send it to your group line, and third, prepare for a quiz next meeting. Alright? I hope everything is good. Okay guys, thank you.